All right, welcome to another episode on prime logic. This is another problem that has baffled and challenged a lot of students. If you want to solve this problem, please pause the video because I'm going to solve this problem right now. So you are asked to find out the area of this inscribed square inside. So we have a right triangle with a side 3, 4. Obviously, you know this one based on Pythagoras, but we'll talk about it in a minute. What is the area of this inscribed square? So now let's talk about it. At first, so this is the first thing is finding the hypotenuse here. So according to Pythagoras, so a squared plus b squared equals c squared. A squared is 9, b squared is 16, so which is 25. In other words, c equals 5. So the hypotenuse here obviously that's 5, and that's a classic 3, 4, 5 right triangle. Let's now prove that these little triangles are similar. So they are similar, but let's prove it. Let's just name this angle as alpha. Let's just name this angle as beta. So alpha plus beta equals 90 degrees, right? This angle is also 90 degrees because that's a square. And this little triangle, alpha plus something, must equal 90 degrees, but we assume that alpha plus beta equals 90 degrees. So this is beta. If this is beta, then this is alpha, then this is beta, and so on and so forth. So all these little triangles and the biggest one, the big triangle, are similar. It means that you can just write down these relationships and the proportions, okay, based on the corresponding sides. Next step is if you find, let's name the side of this square as x. If we can find, for example, the value, the length of this little segment here in terms of x, and this bigger segment here in terms of x, then we can just sum them up, we can add them together, and the value must equal 4, right? So let's name this one as A, this little one here, and this bigger one here is B. So we know that A plus B equals 4, right? This is the side of the triangle. But how to find the value of A and B in terms of x? So trigonometry, that's your answer. Let's focus on the sine of alpha here. So what is the sine of alpha? Sine of alpha in the big triangle is opposite to the hypotenuse. So opposite is 3 and hypotenuse is 5, right? So this is the sine of alpha, but we can also find the value of sine of alpha, for example, in this little triangle on the right side. What is the sine of alpha here? The sine of alpha here is also the same formula, right? But the values are different. The signs are different. The sine of alpha equals opposite to the hypotenuse. So opposite here is x, hypotenuse is b. So sine of alpha in this little triangle is x over b. Okay, I think that's now easy and obvious. We can just express b in terms of x. So let me write it down here. B equals x over sine alpha. In other words, b equals x, okay, over sine of alpha, which was 3 over 5. Let's just simplify that. So 5x over 3 equals b, right? So this is the value of b in terms of x. Now let's do the same thing here for a, but we can't use sine, because if you use sine in this little triangle, if you use sine, the sine of alpha would be, for example, the sine of alpha would be opposite, okay, to the hypotenuse. So opposite is this side. We don't need this side. We need this side. So in this little triangle, we need the cosine. So what is the cosine of alpha in this little triangle? So the cosine of alpha is a adjacent over hypotenuse, right? So hypotenuse is x, which is the side of the square, and a is the adjacent side. So a over x. Okay, interesting. But what is the cosine of alpha? Cosine of alpha we can return to this bigger triangle. Cosine of alpha in this big triangle is adjacent to the hypotenuse. So in other words, 4 over 5 equals a over x. But we need a, right? A equals 4x over 5. Okay, now it's 100% clear now. So we have b here and we have a here, and we know that a plus b equals 4. Let's just add them together. So what is b? So 5x over 3 plus a, 4x over 5 equals what? Equals 4, the side of this big triangle. Let's find a common denominator here. So that's 15. So let's just write it down. 25x plus 12x equals 4. So this upper side is 37x, and then we can cross multiply. So 37x equals 60. In other words, x equals 60 over 37. And that's it. That's the final answer, but not obviously. So that's the side of this square. But what is the area of this square? Area is the side squared. So the side, which is 60 over 37 squared, which is 3600 over 1369. That's the area of this square. But there is a little another. So that's the final answer. But for those of you who are into geometry, into the specific use cases of geometry, for those of you who are nerds in geometry, there is a formula for this. So we don't need all this equations and things like this. So there is a very, very fast formula, but it works under just this setup, under just this a specific setup. So whenever we have a right triangle here, and then we have squared inside, inscribed inside with one of the sides. So one of the sides of the square must be exactly on the hypotenuse of this triangle. So whenever we have this set up, then we can write down the side of square, the side of a square, there's a formula for that, equals ABC over A squared plus B squared plus AB. What are A, B, and C? So A and B are the sides of the triangle, and C is the hypotenuse. Okay, so C is the hypotenuse. So let's just substitute now. It's very easy. So side of the triangle, side of this square equals A times B times C. So 3 times 4 times 5 over A squared, which is like 3 squared. Sorry, so 3 squared 9 plus B squared, another side, which is 4 squared 16 plus A times B. So 3 times 4 is 12. 3 times 4 is 12 times 5, 60. And then we have 9 plus 16, 25 plus 12, 37, right? So that's the exact same thing that we found here. But obviously, so you're not expected to know this relationship, to know this specific, and there is no use case. I'm not into knowing all these specific conditions of formula. So you just need to know the problem from inside out, like this. The first method that we talked about, this is the right method, like finding the hypotenuse, proving that these little triangles are similar to one another, then kind of finding a way to express this side and this side in terms of x. So you could use another way. So this is not the only way. You could use this side and this side. You could use this side and this side and this side in terms. For example, you could use the tangent of alpha. So anything that you'd like. You could use similarities in triangles without even using the trigonometry. So anything is possible. Any approach that leads to this number, the final value, the final answer is okay. But I want you to drop your thoughts and answers. And if you solved it using a different approach, please share it in the comments below. And I think that's going to wrap it up for today, guys. And please like the video and subscribe to the channel if you haven't already. And see you on our next video on prime logic.